Hello, my name is Dmitry Chiak, and I am a member of UCR RoboSub of the software team, and I am working on the graphical user interface. So this is our graphical user interface. Right now it is currently pretty bare bones. It only really has a compass, but it is significantly faster than typing in a command. Right now it's not getting data from ROS. For demonstration purposes, I am just manually inputting numbers to change the needle on the compass. And normally this would be hooked in automatically, and it would just be getting data from the sub. So for sensor optimization, to get data from the sub, we'd have to type in a console command, and this console command is pretty long and it takes quite a bit of effort. We'd have to type in Rust, topic, echo, and then we'd have to tab through a whole bunch of stuff before we could get the right topic, and then we'd have to choose that, and then that would finally print the data we needed. But that's really slow, and it only gets data for one topic. So we want a much bigger picture of what the sub is actually seeing, doing, and what data it has. And we also want to have it show in a much easier to interpret way. And so to do this, we're making a graphical user interface. So normally, when we are using the compass, we'd have it hooked into ROS, and I would not be inputting manually, but I have switched it to input manually for demonstration purposes. And so, like this, we can implement a whole bunch of other widgets that will display the telemetry from the sub in a much easier to understand and see way.
Hello, my name is Mars Nicolaitis and I worked with computer vision and the simulations. So the camera with computer vision gives us some of the most important feedback to the system. So in order to test out our computer vision code, we used the Gazebo robotic simulator. And our computer vision uses the DarkNet framework with YOLO v3 for object detection. And so we used the simulation to test things out, like how many images would be good for training and how long to train our model. But we also use it to make some adjustments to the actual detection process. So if you see here, we have the submarine right here, we have the flat buoy right here, and the triangle buoy right here. And so, for example, when we run our DarkNet ROS node, you'll get the camera feedback, and you'll see what it's detecting. And you see right here, you can see it detects the flat buoy, but it also sometimes detects the triangle buoy. And if you look over here, you'll see the percentage for how possible it is that object. And if you see, it goes above 50% to about 60%. And so in order to prevent that, what we could do is control the threshold value. And so if we raise it up to, since we saw about 60, if we say raise it up to about 75%, and then launch it again, you'll see that it doesn't really detect it anymore as the flat buoy. So after, it's not really showing up anymore. And so that's basically how we would go by adjusting and optimizing computer vision through the simulation. Thank you.